Derivative. Maria, would you like some minion work to do? Would you like some minion work to do? Would you like to do that? Okay, Mrs. Edwards is in room. What's that? Okay, so go down. You know where the elementary school cafeteria is? Okay, walk towards. So you know how the canyon looks like this? Walk down to the middle school, elementary school cafeteria. The first room on the right is Mrs. Love's. The second room on the right is Mrs. Edwards. Just say you're from Mr. Beckman's class and you're here to help a bulletin board. And then if you see Ben, my son, tell him I said hi. Look for the kid whose hair looks unbelievably insane. He needs a haircut so bad, but he's saving it for St. Baldrick's. No, sorry. But you probably have time on Wednesday. All right, today we are going to cover a weird pair of sections. We're going to cover 4.8 and 5.3.
Hey, get over here.
Show your camera.
Oh, kind of weird. Oh, I don't know how to do that on this one. Uh-oh.
Oh, wait, no.
All right, hold on. For those of you watching on the internet, apparently I got a new projector while I was gone on Friday. I don't know how to switch it backwards real quick. I'm going to have to do this.
No, I've never taken
Yes.
math, like ever.
Uh-oh.
I have zero.
You should change RGB.
The only class I've taken
Hold on a sec, hold on.
physics, and I don't know what's happening in this. Like zero.
You don't have that kind of speaker, right?
I think you'd have to change the lens.
Try changing the language.
Yeah, do the one with like the
lens.
swirliest numbers.
Swirliest numbers.
Uh-oh.
Image
options.
Yeah.
Hold on. I got to figure this
If
out.
all your math classes
Okay, which one's
fought,
better?
which
A
one would
or
win?
B?
A.
B.
A.
Okay. Now, how are we going to change this?
Go to image options.
Image options. That didn't have anything.
Why can't you change the
Oh,
word?
excuse me.
Change what?
SOPA.
Well, on my other projector, I just had I found out how to do it, so I just had this shortcut to do it. I don't know how to do it.
The bubbles have like film, and then just goes up like.
Oh.
It's awful.
It's an NEC.
NEC.
Alright, let's just read it off.
Yeah.
Hey Jared, I bet Jared.
What is a letterbox?
Why would I press the blue glass?
He's like, dared you, idiot.
I know that.
Triple dog.
Well, I don't know.
ME331W.
Looks like we're using the whiteboard themes.
Well, hold on.
I
I have.
like the whiteboard.
Sorry, Marshall. We may be using the whiteboard today, buddy.
Sucks for him.
Jesus. Oh. Pray with me. Yay, it worked. Oh, we're on the internet. Marshall, you got lucky. All right, today we're going to take a look at 5.3 and 4.8. What's that?
Did that just invert the image so when it's actually recording, it's going to...
Yes, but YouTube's smart enough to figure that one out. No joke. If you actually record it backwards, YouTube's smart enough to figure that out. Because otherwise, everybody's little selfie videos they make and then upload would be all backwards. So it's actually smart enough. Okay, today we're going to do a couple weird things. We're going to look at the integral, and we're going to look at the first fundamental theorem of calculus. Okay, Nate, seat, please.
Okay.
Your real one assigned to you. Please don't make me treat you like a middle schooler. I'm not.
4-8.
Yep. Fundamental theorem of calculus. The first fundamental theorem of calculus.
I feel like we should have learned that earlier.
All right, now I want to treat you like high schoolers. That means your phones need to be away. You need to not talk when I'm talking. And if your hood's up, you have to put it down. Why? Because we're not a gang school yet. First, f of x is the antiderivative. Big F. Yes, it's a big F. It doesn't matter if the x is little or not. Big F of x is the antiderivative of f of x if f big prime's derivative is equal to f of x. So this is our first definition in this, and you've probably kind of figured it out. This is how it's going to work out, especially if you're in physics. F of x is the antiderivative of f if f prime of x is equal to f of x. Oh, yes, for all values in the domain of little f. So the symbol right here is going to be called the integral symbol. It looks like a really lazy f or a really lazy s, depending on which one of the two you want to use for it. The integral is asking the question, whose derivative is f of x? What's that equal to? Big F of x. So far, we've just found this by taking those rectangles and finding the sums. We could use the left hand, the right hand, the midpoint method to find those three. We've talked numerous times about if you make the number of rectangles go to infinity, which makes the width of the rectangles as close to 0 as possible, you have an exact number. If you use any other method besides that, you have a good estimate, but not an exact number. So what's the integral of f of x? It is equal to the antiderivative of it. If you took the derivative of f of x, that would be back to f. Now, it's kind of weird because all of this is in 4.8. All of this is in 4.8. They actually put it at the end of like the applications chapter. Seth?
Since we're probably going to find approximates, should we use the approximate symbol instead?
This is exact now. So what is this doing? Yep. This is equal to the limit as n goes to infinity of the sum of delta x times h of n. N goes to infinity, yep. So in other words, as the number of rectangles goes to infinity, that's an n. No h in this one. That's a really clever n, though.
That's changing x on top of it.
Yep, change in x. Because the change in x is going to go to what? 0 as n goes to infinity. If you sum up all of those as n goes to infinity, remember, you can't do that. Actually, if you came into the class next period, we're actually doing integrals that have infinity in them in Calc 2. But if you took the limit as n goes to infinity, that would give us the exact area under the curve, which is why we now have an equal sign, not an approximate sign. No, let me rewrite it. Multiply. Because to find the area, you take the width times the height. This is the height, this is the width. So it's multiply. Make it rounder for you.
My soul is cold.
Sorry. Correct, yeah. Delta x the width by h the height. Guys, and let me treat you like high schoolers. No, go ahead.
I just like, is the n like a little n?
Little n, yeah, because each different rectangle is going to have a different height. So the height of the first one, height of the second one, height of the third one, height of the 10 gazillionth one. So the antiderivative is finding the area under the curve. But we know to find the area under the curve, we have to have endpoints, which comes later today, not yet today. So let's take a really easy example and talk about the integral of 1 dx. Now, this dx is important because it's telling us what we are taking it with respect to. Really lame stars there. That is important because it's telling us what we're taking it with respect to. It could be a dt, it could be a dr, it could be a dk. Well, we know whose derivative is 1, x, but there could have been a what in there? Yeah, there could have been a constant. So what do we do when we evaluate this? We know that x comes from the 1, but there could have been a constant. And we call that an arbitrary constant, where c is called the arbitrary, geez Louise. are the constant of integration. This is called the arbitrary constant of integration. Now, could it be equal to 0? Absolutely. Could it be equal to something else? Yes. All we have to do to find that is be given some sort of initial condition, or like where did it start out with? So today is about the very intro to undoing what we did last semester. Last semester we found derivatives, who has an instantaneous rate of change. Now we're going the opposite way. Whose instantaneous rate of change would be this? So a lot of what we're doing is undoing what we did last semester. Who did this? Because once we have rate, if we accumulate rate, it gives us total. I think this is Leibniz. Ask Caleb Neal about Leibniz. That's his boy. All right, let's take a look at a little bit harder example. In fact, let me give you 3. Example number 1. Example number 2, the integral of x dx. Example number 3, the integral of sine x dx. And example number 4, let's go for the integral of 1 over x dx.
What was the example?
We did the integral of 1 dx. Should have put an example 1 next to that puppy because that was our first one. Yep. X plus c. Yep. Because if you took the derivative of this, what do you get? 1. And that meets our definition up here. The integral of f of x dx is equal to the antiderivative of f of x, whose derivative is 1 x. And then there could have been some constant in there that we'd have to be given more information to find. So yeah, that's it. All right, 3 problems. You're answering the question, whose derivative is equal to this? Whose derivative is equal to this? And ready, set, go.
Number 4. Would that be natural log?
I can't tell you yet. Mark's good, set, go.
You don't know either?
No.
All right, who's derivative? Compare with the person around you real quick. Compare with the person around you real quick.
The only one I got.
What's the derivative of cosine? What's the derivative of cosine?
Proms at Gatsby.
Rex.
Yeah.
So it'd have to be negative.
It's got to be negative cosine. Plus c.
Ever seen that?
Cosine of x
But that's a pretty cool thing.
plus c. I know. Whatever constant. There could be a
Whoever
constant.
charged it.
That's what I said. I was like, whoever does this.
Yeah, whoever did this, they get an A+. Who's the senior friend or the juniors?
Who did
She's in the light.
Oh my god.
Look at the dead. That's cool.
Winter.
Try it
Oh
again.
god.
All right, who wants to volunteer the person next to them?
I'm sorry.
Sweet. Alex, whose derivative is x?
It's half x squared plus c.
Okay, question, why do you have to have that half there?
Oh.
Yeah, if you take the derivative, that 2 is going to come down, so you have to have that 1/2 so it goes away. Hence why it has to have that 1/2 up front. Nice job. Well, I'm going to give you a formula. We like to give you the formulas thing. Now, the antiderivative answers the question, whose derivative is this? Whose derivative is that? Well, it's x squared. But because when you take the derivative of x squared, power rule, you bring the power down, you have to have a 1/2 in your answer. so that when you take the derivative, it goes away. No.
Because all of these are open, are we gonna just add plus C?
Correct, yeah. And we'll get there today. That comes with the first fundamental theorem of calc. Jay, okay, other questions? All right, so let's put that together. If we had x to the fourth, what would the integral of that be?
X
No, 1/3 x.
Wrong way.
3.
Whose derivative is x to the fourth?
1/4.
That would have to be x to the 5th. Right, you have to go up a power. Exactly. That's
Oh my God.
And that's what you have to figure out by then. So let's go down below and let's write in a rule real quick. So let's write in integral rules because I know, of course, we're going to want that. Integral rules. Number 1, the integral of a constant is equal to x plus a constant of integration. The integral of a constant is equal to x.
But it's not, the C isn't constant.
Correct, not that. So let's denote this as C1. And in fact, what would have to be in front of that x? Yeah, notice, yeah, C1. Notice I left a little space in there too. The constant has to be in there because you're answering the question, whose derivative is this? What's the derivative of x? Not a constant, so you need that constant up front so it goes out. How do you check these again? Take the derivative of this, it should give you what's inside that. Take the derivative of this, it should give you what's inside that. Second, what if you've got x to some power? The integral of that is equal to x to 1 more power divided by that power plus c. Okay, a dumb one. What's the integral of 0 dx? Whose derivative, yeah, is equal to a constant. Yep. It's kind of odd. The constant of integration is the answer. The constant of integration is the answer to that. So zero's derivative is what? Yeah. Now, could that constant be equal to 0? Yeah, it could be, but it could be equal to 7 too. Could be equal to 7/9. All right, let's go back up here. What's the integral of sine? Kind of tricky. Whose derivative is sine? Negative cosine, right? Negative cosine plus c. Now, you may have heard of a student named Mohit. I won't identify his last name on the internet, but he is quite famous. At some point, you'll have to take a memorization quiz on this. You got to get 100% on it. He didn't study for it, so literally he wrote on the top of his, and I'm not acknowledging religion here, just a student's response on a quiz. Mohit wrote at the top, I didn't study for this, but I heard the answer to everything is Jesus. But Beckman told me every integral has to have a plus c in it. So literally, for the 40 answers, he wrote Jesus plus c. All of them.
Did he get 100?
No, he got 0. Sadly, none of them, that was not the correct integral for that. Okay, a little bit harder one. Whose integral is 1 over x? Yeah, so this is equal. Now, we have to be a little bit careful on this. This formula down here works as long as n does not equal -1. As long as n does not equal -1, because this is x to what power? -1, right. The negative, because when it's in the denominator, it's negative. This is x to the -1 power. Let me finish this off. Plus c.
What if it's like,
Now, hold on. I'm not even done with this. Hold on.
Oh,
The natural log can only take what is in its argument. Like the argument, cosine can take anything in its argument. Natural logs can only take what? Positive value. So how do you make sure this is positive? You put absolute values around it. Now, if it's x squared in there, yeah, then you don't have to put absolute value. Anything squared is going to be positive. So down here, there's one more rule. This doesn't work when n is equal to -1, because when it is equal to that, give me just a second, Nate. It's equal to the natural log of the absolute value of x plus that constant c.
That's like 1 over x squared.
1 over x squared?
Yeah.
Then we follow this rule. So let's do that one real quick. Nate, then I'll get your question. I forgot about you. Oh,
All the intervals.
no. In fact, as soon as I wrote that E, I wrote that. Do I want to do this real quick? Do I want to do this real quick? Okay, you don't have to write this one down. You don't have to write it down, but let's just do it real quick. Example number 5, and ignore that E real quick. Example number 5. What about the integral of 1 over x squared?
right?
No, you don't cry, because this is just x to what power? And this rule works except when it's equal to what? Yeah, so this is x. What's 1 more power than -2? -1 over -1 plus c. Now, here's what I want you to do real quick. So you know that I'm not just making this up. Take the derivative of this real quick. It should give you what?
1 over x.
Yeah, 1 over x squared. Take the derivative of that real quick, either on your head or either in your head or there.
Does it?
Wait, why did?
I heard a lot of words. I didn't hear a question. Okay, so what's the derivative of that?
-1.
-1 times x to 1 less power, which is -2, and then -1 divided by -1 is 1. Okay. Yeah, because that -1's already in. Stop and check out questions on that. Okay, let's get you some other. Are we ready? Should I just write all the integral rules here?
Yeah.
Okay, let's go for 5. I could have you discover these. The integral of e to the x dx. I'm sorry, Christina. Yes, I can.
X.
What's the derivative? Whose derivative is e to the x? Yay! Now you can see yourself saying, well, what about chain rule problems? Okay, yeah, what about chain rule problems? We'll get there. We're not ready for that quite yet today. So the integral of e to the x dx is e to the x plus that constant c of integration. What about the integral of some other power? No, let me make that generic. A to the x power dx. Because it doesn't just work for 2, it works for all values. Well, what's that equal to? That's equal to a to the x over the natural log of a plus some constant c, as long as a is greater than 0 and a does not equal 1. Now, real quick, why is it? It actually would work when a is equal to 1, but if you have 1 to the x power, that's always equal to what? 1. Yeah, so it's just really trivial. Really trivial. That is an A, by the way. 7, we just did this one. The integral of sine x dx is equal to negative cosine x plus c. Guess what's coming next? What's the integral of cosine? Sine. No.
Wait, why can't a be equal to?
Because then it's just 1 to any power is equal to what? Kind of.
1?
To any power is equal to
Oh,
1. Yeah, and then what's the integral of 1? Much easier than that. Now, the good news is that actually still does work. But if you've got the integral of 1, you're just going to write it as x plus c. You're not going to mess around with that. All right, integral of secant tangent. Whose derivative is secant tangent? Secant, right? Well, days are coming back. The integral of secant squared. Whose derivative is secant squared? Tangent. The derivative of, what's another one we know? Cosecant cotangent. No, it's not equal to Jesus. Sorry, don't copy off Mohit on this one. Cosecant x plus c. What else is there? Cosecant squared. We didn't do that one yet. Oops.
The negative cosecant.
That is not a negative cos. Oh, isn't it negative cotangent? Oh, sorry. Yes, that is a negative cosecant x. Yep. Sorry, I thought you were talking about this one. I'm pretty sure it's cotangent. Is cosecant negative? Nope, it's negative. See, you were right. I should have listened to you, even though you weren't talking about the right problem. Is equal to negative cotangent x plus c. Did I give you the section on hyperbolic derivatives?
Yeah.
For like a day.
Yeah, well, that's all I needed to cover because all you really have to do is memorize it. Did I say that out loud? Yes, the integral of sine hyperbolic x. The good news is that it's cosine hyperbolic of x. 14, the integral of cosine hyperbolic of x is equal to sine hyperbolic of x. Yes, all your dreams come true. And then, do we talk about sine inverse, cosine inverse, tangent inverse? I assume we had to. 15, the integral of, what is it, 1 over root. Should be smarter next year, just type this. Yeah, absolutely. 1 over 1 minus x squared is equal to sine hyperbolic of x. No, it's not. It's just sine inverse.
I got every one of those.
And then x has to be less than 1. 16, there's only 2 more. Integral of 1 over
tangent.
Yes. These are the 17 you have to have memorized. Now, the vast majority of them you're going to know. Probably the last 5 you're going to have to actually like physically memorize.
Integral of 1 over 1 or root 1 plus x squared.
Nope, close. X times
Not even.
is equal to secant inverse.
What happened to cosine?
It's ugly.
Okay.
Ugly. It's hard to find something whose derivative is that.
How many kids on average fail these?
Very few.
Actually,
Chapter 5 is, I think, the best test of the whole year, actually, because basically you've been doing this all year. Now you're just undoing all of it. I mean, it's basically like, you know, the Monday after prom. You've been trying to get a boyfriend all year, and now can't wait to get rid of him because the only reason you were putting up with him is because he was going to look cute in prom pictures. Then he didn't give you a graphing calculator, and now you literally have no reason to keep him around anymore.
What is that supposed to be sine -1 of x?
Sine inverse of x. Don't let Breebach hear you saying sine to the -1. He will beat you.
They're just starting their trigonometry again.
Yes, I heard the Tears first period today.
Ooh, can you go like bombard them?
No, we let them have their emotional insecurities.
Could also
By
have the door
themselves.
just screaming like different.
Seriously, we win a state academic championship, and I've got multiple kids ineligible. Yeah, we won the 4A state academic championships this year. It doesn't matter what their grades are anywhere, any day except the very last day of the semester. Yes, we have 17 kids who are academic all-state first team and 9 kids that are academic all-state second team. What's that? Gotcha. You were? Are you going to make that? Do you have 3.75? Unweighted?
yeah.
You should. You should then. Noah, yes, sir.
What's the number 17?
The whole team is
Secant inverse of
It
x
looks like
plus.
DCC.
What's that?
It looked like
Oh, it does kind of look like DCC.
Yeah, I saw DCC. And I couldn't.
Yes, it's equal to DCC's inverse, the school that made DCC.
Integral of CC.
What, 17?
Can you go back to 10? I
Sure.
missed that one.
Yeah.
I didn't remember.
Secant squared of x. Yeah.
He's not here either. I'm positive he's probably watching my class online right now, but he's not here.
0 view. He was watching.
He could have been watching. Well, I like to think that he will be watching one day, hopefully, maybe.
No. No. I won't.
All right, now, all of this is basically undoing what we did last semester. Whose derivative is this? Whose derivative is this? Okay, so let's,
I sent that though.
am I done with this?
Oh, Jeffrey's got his money. Give the money back to him.
Gotcha.
So it's stack of money. Where are you?
Because when people don't get set
Long story, but Caleb Neal gave me money to give to Ryan Jeffries. Let's think of somebody who's more likely to forget something than Beckman. Nobody. So, of course, I forgot about it. So I literally had this money in my jeans pocket. So then I washed my jeans. And then, of course, I'd look in the pockets as I'm folding. I was like, sweet money. And then Caleb reminded me it was actually his money. So then I told Ryan, I was like, okay, I'm going to put it in the fridge. Nobody will ever look there. Just go get it on Friday. And then, of course, what happened? Ryan also forgot it. So, hey, Marshall Garcia.
Run.
Run.
Seriously.
Beckman, I think I might be more forgetful than you.
Okay, so here's what I want you to do real quick.
Here's what I want you to do, please. Yeah.
Yeah.
How do you lock it?
Because I forget to grab them.
did it
like
Wait, but
No, what are you
Nobody
doing?
wants.
It's like,
No, I like this.
Okay.
That's how my program. I
Right.
understand.
Don't drink my Diet Pepsi. You can't buy those. Oh, yeah, you know Diet Coke. That's good. All right. Also, because let's go back. F of x. Also, because f of x,
Right, stats. No, we have a test
I'm
Friday.
going to just be present. I'm not, what is this?
Just a reminder, we have a test on Friday.
I'm not taking this.
I'll get you a burger for a regular.
No,
I didn't say that online. It was a joke. I'm so sorry.
okay, let me finish up so I can get you to examples. There is a point I need to get you to today. I make sandwiches for lunch. There's lunch meat in there.
There's not even bread.
Marshall, look above the fridge.
No, that's not.
Some people's children. All right, let's go. Because the integral is really just a limit, and basically everything we've talked about in this class all year long is a limit, which is why I beat it into your head so much at the start of the year. Because of that, give it to me. Because of that, we can break up integrals by addition. Nah, I think you walk out of today thinking there's not that much to these.
It's like the exact same thing, just the other way.
Yeah.
It's literally.
It literally
like,
is.
you think the other
So
way.
we can break up integrals by addition and subtraction. Notice I put addition first. I'm going to put subtraction second.
That's
If it's a plus, it breaks up by plus. Don't talk when I'm talking, guys. Marshall, hi. When it's a minus, it breaks up by minus. Marshall, I have a feeling like you're going to have to do a lot of listening to Meg this week, so you might as well start right now. And just say, yes, honey, it is awful that judge was on his cell phone your entire first round.
Yeah.
I'm sorry.
I've already gotten.
Good. I'm sure you did almost the instant she walked out of it. Also, if you have the integral of a constant multiplied by some function of x, just like we did with derivatives, you can simply move the constant out and deal C. Let's see. That's definitely not closed. Definitely not. You can just deal with
We do like a C naught. No, that it's not.
you can do a C naught. That would give you the same thing. So what should you know out of this? The constants can come out of the integral. We can break them up by addition and subtraction. So I'm going to show way more work on this one because I'm teaching it to you the first time than I ever will in the future working them. But I'm going to break this down into its individual parts. If you already know or feel comfortable doing it, you do not have to show all this work, but I am showing the work so people who are brand new to this see what is going on in the background, even though you're probably never going to write it past this. So I'm going to take a look. Can you say that again?
I lost you on the last.
Sure. The integral of a constant multiplied by some function is equal to the constant multiplied by the integral of that function is equal to the constant multiplied by the antiderivative of that function plus some constant of integration.
Okay, so if there's just a constant, you always bring out the constant.
You can always bring it out front. You don't have to, but you can. You don't have to, but you can.
Really never changes.
Yep. All right, let's take a look at an example. I'm going to show way more work on this one than I have to. Way more work than I have to. Let's take a look at the integral of 6 over x cubed plus 4e to the x dx.
Break it.
Now, again, I'm going to show way more work on this one than I'm ever going to in the future because I want to show you all the steps. So I just told you that we can break these up through what? Addition. So my first thing I'm going to do is I'm going to take the integral of the first thing plus the integral of the second thing and go from there. All I did is break it up into two different integrals. Now, if you see how to do it, can you just do it in one step? Absolutely. And that's why I'm telling you, I'm showing more work this time than I would ever show doing the problem myself. The next thing is I'm going to take all of these constants out. Now, Justin, I think, asked the question, how many people fail this test? It's really very few. This really isn't a lot of new stuff. It's just it's the opposite direction you've been going in the whole year before. This is actually one of the better tests of the year. Okay, this is a power rule because I have x to what power? Right, so I'm going to show more work than I ever would working it. 6 multiplied by x to the 1 more power divided by 1 more power
Where did -3 come in?
because this 1 over x cubed is x to what power? -3 power.
Or
Yeah.
why is it denominator this one?
It is x is not in there. The power
It's the
is.
rule.
X is not in there. The power is.
But why is it -3 plus 1 not just?
It's +1.
But it is -2. -3 plus 1 is -2. I remember I'm showing more work now than I ever will again. I just don't want to lose people in what I'm doing. Because here's the deal. I've done this hundreds of times. You're doing this for the first time. I don't want you to feel intimidated. You should already get this. We're learning how to do it. Plus 4. Whose derivative is e to the x? E to the x plus, don't forget, this is what's called an indefinite integral. We'll introduce that word in a second, but plus there could be some constant of integration that was in the original problem and goes away when we take its derivative. Stop and check up. Questions on this? Yep, Jordan.
How did it go from x to
This is x to the -3.
yeah?
The rule is if you have x to some power, the integral of that is x to 1 more power divided by the new power. And that's all I'm doing. I'm going to clean it up in just a sec. In fact, let's clean it up now. So 6, -3 plus 1 is divided by -3 plus 1 is. Okay. 6 divided by -2 is.
-3.
So my final answer . All right, stop and check up. Questions on that? Questions on that?
Why do you?
Because it finds the area under the curve. Because oftentimes you can write an equation for rate. Like we can find the marginal profit. To find the total profit, we need to take the antiderivative, which undoes rate and takes us back to position. We will find C, yeah, just not today. And if it's got endpoints, like I tell you to go from 7 to 10, then we don't need plus C because then it's a definite integral. But all we're dealing with right now is indefinites. And it's kind of weird because they put this together and then they introduced how to find Riemann sums and then they come back to it later on. And to me, that just doesn't make a lot of sense. We did. This is actually before. This is actually in the end of chapter 4.
But isn't some just pretty much integral on a smaller level?
Correct. It's an approximation of an integral. Then, as we make the number of rectangles go to infinity, it becomes an exact. All right, I'm going to give you one to try on your own, though. One to try on your own. Let's have you do this. Let's go for the integral of 7 cosine x plus 3x cubed plus 7x plus 4. Okay, and I've lost track of my examples. What number is that? 7.
What? You wrote the last one as example.
No, that was clearly a 6. Clearly a 6.
What?
It's clearly a 6. I don't know what kind of math you were doing this weekend, but that was clearly a 6. And then I'm going to give one that even Marshall can do. Let's look at number 8. Well, in its current state, the integral of x.
We already did that.
We definitely didn't.
Oh, just X.
Just x. All right, on your marks, get set. I'm going to give you 4 minutes to work this out.
What's that with respect to?
I don't know.
The problem is written as I want you to do it. The problem is written as I want you to do it. Now, just come to math moments. Last year when the kids were taking AB, apparently their teachers never made a big deal of this. They went to their AP practice test, which is their final. If you did this, nothing you put is correct. You missed the entire problem. And as we went through last time, these are worth 9 points each. If you did put that and you work the rest of the problem, you miss all 9 points because nothing's correct. On your marks, get set math. Marks, get set math.
The first one is 7 sign. Three over 4x raised to 4 plus 7 halves x squared plus 4x.
Yeah.
On this one.
Nope. Got something in that first one. There you go.
Wait, for the
Thank you.
third one.
You have
hold
also
7
something to
off
pick up in the
X
office.
As a that's weird.
It can.
What else would I say?
Well, if you're rewriting it, yes. If you're not rewriting it, just. No, it's
Yeah, I was like, I don't know how to do that. That's the same thing. It's the same. It is the same. It's much easier because you know it's going to be excellent for it. And you just add one for it.
Yeah.
How is this? Bring up the concept. Or no.
So 7 times 7 times X.
What's the difference?
She's doing 7 X. What's the what's the rate of that?
X
Seven
squared.
X is 7 squared.
7.
Come on, Christina.
All right, compare somebody around you. Oh, no, keep going. Sorry. I underestimated how much time it's going to take.
I honestly have no idea how to do the second one. Like 0.
You should.
I mean, like,
Hint. Jared gave you a very good hint on what was
that's
wrong
I'm
with this.
thinking. But then I'm like, I don't know what to do with that knowledge he bestowed upon me.
You just have to be Finn McCool. Take
Oh, of
knowledge
course.
from the salmon.
Should you eat that salmon?
Yeah.
Stop.
Okay.
So much reading that you have to do.
It is 1/2 x squared d
No.
d x d plus c.
No.
Am I close with d?
No.
I don't know. You know how to do the second one? Okay.
Well, you don't know what taking on perspective, so. Actually, I think really great. Okay, good. You don't know what is expected. Because it could be respect to A.
Ah, you are.
What respect are we taking?
What did you guys give for number 1?
You're supposed to not have to take respect. You always, when you take a verb, you're always taking respect to something. So the respect. The anarchy theory.
D question mark.
Number one.
Does anybody know what's happening?
No.
Okay.
I think it's something.
I had to.
Yeah, I'm not really sure what's.
Nate?
Yes.
Stop talking.
Actually.
That made me.
I don't think. And then this is a
Why is everything on plus?
Because we don't know if there's.
Oh, yeah.
I know what you're saying.
That thing.
Oh, yeah. I want a burger.
Nick, what?
Never mind, I'm not getting a burger.
No, there's just one C.
Whoa.
There's one constant of integration. There's one constant. This is one integral. Remember, you split it up. You split it up. But there's just one constant to this integral. You broke up. There's just one constant. All right, let's look at 8 real quick. 8 is a trap. Jared gave you the hint. What's wrong with 8, first off? Yeah, there's nothing it's telling you with its respect to. There's no solution to this. You cannot do anything with this. Now, if I put a dx right there, then you can find it. In fact, if I put a dt there, you can do it in Calc 3. But with no...
You should show us how it works.
What's that?
You should show how.
Actually, I can totally show you how this works. What are we taking this with respect to?
Time.
Okay, so here's the weird part. X is a what? A variable, but are you taking it with respect to that? No, you're not. So what's the integral of this? Well, here's the deal. Take this with respect to t. The c goes away. You need a dt there, but you already got it. What's the derivative of t? Yeah, whether you're taking it with respect to x, this is like first day of Calc 3, whatever you're taking it with respect to, everything else is treated as a constant. Everything else is treated as a constant. Now, here's the really bad news of Calc 3. That's like day 1 of Calc 3 problem. Here's the real.
The integral of the integral.
Isn't that just like
So the antiderivative of the antiderivative. So first, yes, well, kind of. First you take it with respect to x, and then you take it with respect to t, and then you get your answer.
Why?
Because you can.
Why? Like, what instance would you use that for?
A river's flow rate. Because it has a x dimension, a y dimension, and then also we'd have to take the z dimension too. So when you accumulate the rate of all three, you get the total amount of energy created. Hence, if it's going through like a, what is this called, a turbine, like most, if you don't know, most of the electricity in the US is still produced by hydropower. If it's going through a turbine, it's going this way, and this way. If you accumulate all three's energy contribution, you get the total amount of energy created.
And then you have to work on imaginary numbers.
Well, the problem is it actually produces more than that because there is an imaginary coefficient there, which is the one real life application of imaginary numbers that I'm aware of. So anyways, if there's nothing there, there's no solution. Now, working backwards through that, if you put this as your answer, or you put this at any point of the problem without saying what it's respect to, no joke, they just take out their red pen, they put that there, and you don't get any credit for anything after this because this means nothing. That's why I put it on there, just as a hint. On your test, there's going to be 1, 2 that you cannot find because I didn't put it on there. Why? Because that's meaningless. It means absolutely nothing. No joke.
So you can't write no solution.
If they gave that to you, you'd write no solution. If they gave you that, there's going to be an uproar in the AP community. But on your free response, if you put that as part of your solution, they'll put an X right there and give you no credit for anything after that because that means nothing. That's useless. That's like saying this, like d of cosine of x. That means nothing unless you put d dx. Now we're taking the derivative with respect to x, right? If you just put that, it means nothing. True, unless d is a constant, which is why they never use d as a constant in calculus because it usually means take the derivative of it. Or at least they should. Yes, but that's going to be the integral.
Oh, get ready.
because it's the inverse of that.
Wait, so the inverse.
No, I'm just saying, like.
Oh,
Instead of the,
oh.
fancy, spaghetti.
I wouldn't try it on something important. Let's take the integral of this. Did you break it up or did you take it as is?
As is.
Okay, broke it up. Let's break it up. I don't. Yeah. And Jared said you just do one piece at a time. Yeah, you do.
But if you break it up, it's pretty much good.
Exactly. Yeah.
It's just less
You just
writing,
gotta.
not
You just
breaking
gotta
up.
write it. That's the only difference. Whose integral is cosine? Thank you. You can't see it. Yep. Whose integral is cosine? Do I put a plus C here?
No.
You could, but just put it at the end. Just put it at the end. Who's okay? So this is a power rule. So power divided by power. We'll clean that up in just a second. That's one more power. That's one more power. Plus one more power over the power. Plus, really, there's an x to what power there? No. No.
What?
It's actually
Here.
0.
0. So really, there's going to be one more power. Clean it up just a little bit. There's your answer.
I got it right.
Anybody get it right on their own? First one? Yeah, good job. Questions on that? Questions on that? Questions on that? Yeah, Nick. Yes. They're awful. They're called U subs. They're called U subs. Remember back in pre-calc when your teacher like taught that logarithms unit and they specifically like had something like this?
Yeah.
Oh, yeah, and then you have to factor it.
Yep, and then you like let u equal ln x and do that. The reason why they really taught it that way is so you'd seen this u sub thing before you had to do it in calc, and that's all it ends up being is a u sub. It's really not that bad. Let's show you another notation for this.
There's another one?
Kind of. So let's say dy dx is equal to 3x squared plus 7 to the x. This is called, because this is a derivative. This is called a differential equation. What are they going to ask you to find? They're going to ask you to find the y equals equation that gave you this, which is nothing new than we've done before. Now you're just solving an equation that has this. So to solve for y equals, well, what undoes a derivative? An integral. So what are you going to do? You're going to take the integral of both sides.
So is that what diffie q is?
Yep.
Just nothing but integrals?
Yep. Now, kind of odd. No, that's the entire class is just integrals. In fact, kind of weird. When you actually take the class called diffie q, e to the some power is almost the answer to everything. It's absolutely crazy how the answer to rates in life is e to some power. It's absolutely one of those weird things that just works itself out. Now, the problem is you've got how many rates over here? 2. You've got how many rates over here? So your first step is you're actually going to multiply both sides by dx. The dx's then go away. Then this becomes with respect to x. Whose derivative is dy? Y. Then we'll do the integral over here. Whose integral is 3x squared? Well, 3 times x to 1 more power, which is divided by. Can you still see? Okay, this is 7 to some power. So look up the rule real quick of some number to a power that is a to the x divided by.
Natural log.
Yep, and then don't forget the what?
Constant.
Yeah, plus c. So kind of odd. This isn't anything different. It's just giving you an equation to do it with. How do you solve a differential equation? You multiply both sides by dx. You take the integral of both sides. You get the equation that gave you that. So now, if you took the derivative of this, you would get this differential equation back. This, give me just a second, Seth. This is called the general solution. If they gave you one point that it went through, it would be what's called a exact solution to the differential equation. So this is just a general solution because it gives you some plus c. Later on, we'll go back, give you a boundary condition, and talk about slope fields and that, but that's all we're going to do for that. You could do it twice too. They could give you a second derivative. You could take the integral twice and get back to the original equation.
So is that, like, if you just factor out the 3, it's just x cubed.
Right. And I should do that. Now, Christina asked, can we find C? Yes. And if you haven't noticed, I'm kind of avoiding that today. Why? Because it's not really what, don't want to go that far today. That is as far as I'm going to go, though. Stop and check out questions from you all. Because I do want to give you the assignment. Let's look at page 2370, which is section 4.8. Again, kind of odd. I did not get to 5.2 today. I did not get to 5.2.
That's all 4.8.
Yeah. In fact, that's not even all of 4.8. I did not get to the non-rectangular motion or the second derivative problems. So tonight, all you have to do is find antiderivatives. So you're going to do 1 through, yes.
1 through yes.
1 through 1 odd, just do all.
1 through 1 odd?
Yeah.
How about 1 through 4?
1 through 1.
And then 9 through 29, the odds. 35. Heck, you can say 1 through 35.
Oh my god, I suck.
We did not talk about that.
What'd you do? Took a geometry test. I missed 7.
And then page 372, 29.
Wait, was that 7?
3.
I'm okay with 7%. Yeah. They were like 20 questions.
Page 372, number 3 only. We'll finish that up. We'll get to 5.2.
You got like
Hey,
not even one. You got 1.5 right.
Hey, Vic,
Yep.
I'm not going to be here Wednesday nor Friday.
Okay.
So
Watch online.
I'm,
What's that?